In this example, we are going to rewrite the expressions as a product and simplify if possible. The first one, we have the sum of sine of 13x and sine of 3x is in the form of the sum of the two sides, which the same as the pattern of the formula number 5. So we're going to name an angle A or alpha as 13x and beta as 3x and follow the pattern of the formula number 5 and rewrite this as the product to get 2 multiplied by sine of a half of the sum, which is 13x plus 3x divided by 2, multiplied by cosine of a half of the difference, the alpha 13x minus beta, which is 3x divided by 2. Simplify as much as we can. Then we have 2 times sine of 13x plus 3x, that's 16x. 16x divided by 2, simplify to be 8x. And then multiply by 13 cosine of 13x minus 3x or 10x as a numerator, divided by 2, reduce, and becomes 5x. Now we rewrote the expression sine of 13x plus sine of 3x as the product, and we are done. The next part, or part B, we have cosine of an angle plus cosine of another angle, which in the form of the cosine plus cosine, which is number 7. Okay, for number 7, I'm going to put a note here. So number 5 is used for part A and number 7 is used for part B, where alpha is 7 pi over 12 and beta is pi over 12. And then follow the pattern of number 7, cosine alpha plus cosine beta equals 2 times cosine of a half of the sum. So going to be 7 pi over 12 plus pi over 12 divided by 2. And then multiply by cosine of the difference, 7 pi over 12 minus pi over 12, all divided by 2. Oh, sorry, wrong one. Subtracted by pi over 12. I was wrong. So this is pi over 12 because alpha minus beta and all divided by 2. Next, we're going to simplify the expression or the quantity for each cosine. The first part, 7 pi plus pi over 12, that becomes 8 pi over 12. And simplify further to be 4 pi over 3. For the difference of 7 pi over 12 and pi over 12, we get 6 pi over 12, which is pi over 2. Now, we have fraction on top of the fraction. I'm going to rewrite to avoid the confusion in algebra as divided by 2 is the same as multiplied by the reciprocal, or we write as a half of 4 pi over 3 as a result from the sum times the cosine of a half of pi over 12 or pi over 2. That is the result from the difference of the two angles. Now, simplify further for the product of the argument of the cosine. 2 and 4 reduced to be 2. And then these two combine to be multiply to be pi over 4. Therefore, we get the expression as 2 times cosine of 2 pi over 3 multiplied by cosine of pi over 4. 2 pi over 3 and 4 and pi over 4, they are exact. They are real number. So then we gonna find the exact value for those. So from the side notes, 2 pi over 3. If you prefer to do in the degree form. So multiply by 180 degrees divided by pi, or this one becomes uh, 120 degrees. Okay, and 120 degrees is in the second quadrant. For the cosine of 120 degrees is negative cosine of the reference angle, which is 60 degrees. We use the right triangle diagram all the time to get the exact value out. For 30 degrees, square root 3. 60 degrees, adjacent is 1. And then opposite, hypotenuse is 2. Then the cosine 120 degrees without using the calculator going to be negative of the cosine 60 degree, which is negative 1/2. For the pi over 4 is the same as 45 degrees. You can use the formula, the conversion to convert into the degrees if you are not sure. So this becomes 45 degrees. And then the right triangle diagram for the 45 degrees can be used to get the number. Since 45 degrees, the two legs are the same measurement, and then the hypotenuse is going to be square root 2. Therefore, the cosine of pi over 4, which is the same as cosine of 45 degrees, is 1 over square root 2. Then we're going to replace the cosine of 2 pi over 3 and cosine pi over 4 with the value that we found on the side notes here. Simplify further, we have 2 times cosine 2 pi over 3 is negative 1 over 2. Cosine pi over 4 is 1 over square root 2. And then simplify completely to get negative 1 over square root 2 as a final result.